Good morning. All right. So in our previous lesson, we learned about the difference between precision and accuracy. And we also learned that if you are given measured values, there is a way to determine whether those measured values are accurate or precise. So to simply know that the measured values are accurate, we usually use average value and then compare it to the actual or true value. So the one with the that is closer to the true value will be an accurate measurement. And as to the precision, to measure whether a measured value or values are precise or not, we usually use relative average deviation or average deviation to determine whether the measured values are precise or not. So in our today's lesson, before I proceed to today's lesson, do you have any question on this concepts? Also, remember that the value, a low standard deviation or average deviation standard deviation indicates that the measurement or the measured values are accurate, whereas a high standard deviation or average deviation indicates that the measured values are less precise. So you should remember all these points. So these are very important concepts in chemistry. So you have to remember these two concepts, precision and accuracy. They are not the same. They don't refer to the same concept. So you should differentiate these two concepts. Now, let us proceed to our today's lesson, which is determining error. So now, before I define what an error is, let us define what an accepted value and experimental value refers to. So remember, accepted value is the correct value, which are based on reliable references. Experimental is value measured in lab. So the difference between experimental value and accepted value refers to an error. So this is very simple. So error refers to the deviation from the accepted value. So it is simply given by this equation, which is experimental value minus accepted value. We'll see with an example. Now, the other point is percent error. So if you're asked to calculate percent error, it will give you, percent error is given by the absolute value of error over accepted value. Times, of course, 100%. So this is percent error. So remember, error can be positive or negative because it depends on the value of experimental value, right? If the experimental value is less than the accepted value, it will be negative. And if the experimental value is greater than the accepted value, the error will be positive. So error can be positive or negative, depending on whether the experimental value is greater or less than that. Now, when you calculate the percent error, you have to take the absolute value of error divided by the average value times 100%. So this is how you can determine percent error and error. So let us explain this concept using an example. For example, suppose you use a thermometer to measure the boiling point of pure water at standard pressure. The thermometer reads 99.1 degrees Celsius. So you probably know that the true or accepted value of pure water is 100, right? So you will be given this value. So if you are asked to determine or to calculate percent error and error, how would you calculate? So error is defined as experimental value minus accepted, right? So here the experimental value is 99.1 degrees Celsius minus the accepted value is 100 degrees Celsius. So the difference is 0.9. This is negative degrees Celsius. So this is error. If you are asked to calculate percent error is equal to absolute value of error over the true value or accepted value times 100. So the absolute value of 0.9 is minus negative 0.9 is 0.9 over the accepted value is 100 degrees Celsius. 100 degrees Celsius, right? Times 100, and this will give you 0.9%. Is it clear? So here you have the answer, 0.9%. Any question? All right. So there are two types of errors that are related to precision and accuracy: random error and systematic error. Now, let's see what these two terms refer to. So systematic error produces values that are either all higher or all lower than the actual value. So if you are given a certain value and also the accepted value, to determine whether the error that is incurred is systematic error or, hold on, let me take this call, okay? Hello? Hold on. Double check. All right. So to figure out whether the measured values incur systematic error or random error, all you have to do is compare the values, the measured values, to the actual. If they happen to be all higher or lower, then we can say that the error that is incurred is systematic error. Okay? Is that clear? Now, so this always results in a particular direction, because all the values are what? Either they are higher or lower. So they are skewed to one position because all the measured values are either lie to one side or to the other side. So this type of error is called systematic. So systematic errors arise from the flaws or defects in the instrument or in the manner that the measurement was taken. So systematic errors can happen from defects in the instrument or from the manner that the measurement was taken. For example, if you are asked to measure the volume of a liquid, and if you don't read the meniscus, for example, so this is what meniscus is, right? So if you read this point, you will incur such type of error, because when you take a reading, especially when measuring liquids, you have to read at this point. We call this level the meniscus. So instead of reading here, if you read this, the error that you will incur will be systematic error. So this is one very important point that you have to remember in regard to precision and accuracy. The other is random. So as you can understand from the word random, that the values are both higher and lower. For example, let's take an example. So let us assume that the accepted value is 2. Now let's have student A and B. If student A measured 3, 4, 5, 6, 1, 4, 3, 0.5. Now, so looking at these two examples, for example, taking the first one, A, assuming that the accepted value, is 2. And if you measure 3, 4, 5, or 6, now because these measurements all lie above the accepted value, that we can say that the error that is encountered in this case is systematic, because all the values are higher than the accepted value. In case B, it will be random error, because these values lie on both sides of the accepted value, because some of the values are higher than the accepted value and the other two are lower than the accepted value. So in such a case, the error that is incurred is random error. So this is how you can differentiate whether the error encountered is systematic or random. So in random error, the values are on both sides of the actual value or accepted value. So now, look at these two. Which of these is less precise? As you can see, these values are spread apart. Therefore, when you have random error, they make your measurement less precise, but not in any particular direction, because they are not skewed, because they lie on both sides of the accepted value. Okay? When we say not in any particular direction, we mean that the values are not skewed to one direction. Now, how can this be incurred? They can arise mostly from limitation in the instrument. So random error can be incurred due to the inadequacies of the instrument. All right, let's see with an example. So here in the first figure, as you can see, the values are spread. Now, because the values are spread and they lie above as well as below the thank you. All right. All right, so because these values lie on both sides of the accepted value, we can say that the error that is incurred while measuring is random error. All right. Now, as you can see, these values, when you calculate the average value, the average value will be closer to the actual value. Now, if you have random error, the accuracy is not affected as much as it's affected by systematic error. Why? Because the values are spread apart. But when you take the average of these measured values, they will average out. Therefore, the accuracy is not affected as much as it is affected by systematic error. Now let us see this. But here, the precision is less in case when you have random error. In systematic error, remember the values are in higher or lower value than the accepted value. So here, all the values are above the accepted value. So here the precision is not affected as much as it's affected as in the case of random error. Here, the accuracy will be what? Less as compared to random error. So when you have random error, accuracy is not affected, rather it is precision that is accepted, that is affected, whereas in systematic, the precision is affected, but the accuracy is affected, but precision is higher than when you have random error. So that is the main difference between these two types of errors. All right. So now let's see let's summarize what we have been discussing. So precise measurements have small random errors, whereas accurate have small systematic error. Remember, in systematic errors, what we were saying was here, if you take the average value of this, it will be over here, which is different from the accepted value, right? So if you want to have an accurate measurement, you have to have a small systemic error, meaning this has to come around here so that your measurement will be accurate. Here, when you have random error, remember, you have to have small, here, precise measurements should have small random errors. Remember, accuracy is not affected as much as it is affected by systematic error. Therefore, so this is very important. Precise measurements have small random errors, whereas accurate measurements have small systematic errors. Now, do you have any question? All right, so I will give you an exercise to work on these concepts and see how you do. Any question? All right. All right. Now, let's see how you do this. So, a student was asked to determine the density of a block of aluminum and reported as 2.63. Calculate the error and percent error made by the student. Now, assume that this is the accepted value. Can anyone answer the question?
The error is negative 0.07 and percentage error is 2.07.
Excellent. So all you have to do is what? So remember, error is calculated as experimental value minus accepted value, right? So the experimental value is what? 2.63 gram per centimeter cube minus 2.70, which gives minus 0.07. Excellent. Now, to calculate the percent error, all you have to do is what? Take the absolute value of minus 0.07 over the true value is 2.7 times 100%, which gives, how much did you get for the percent error?
2.6%.
2.689. Excellent.
Mister,
Abed.
error ስንሰራ ቫልዩ ስታንከቱ
Experimental value minus
ሲቀንስ accepted value
ወይም ደግሞ ይሄ true value የምንለው ማለት ነው። So assuming ኤረር ምን መሰለሽ፣ አሁን ኤረር ስንል ለምሳሌ ከአክሰፕትድ ቫልዩ ወይም ከትሩ ቫልዩ ሊተልቅም ሊያንስም ይችላል። ለዛ ነው አሁን ለምሳሌ ይሄ አሁን ኔጌቲቭ ምንድን የሚያሳይሽ that the negative value indicates that your measurement was smaller than the accepted value ማለት ያ ነው የሚያሳየው። ትልቅ ሲሆን ደግሞ ወይም ፖዚቲቭ ሲሆን ደግሞ ከአክሰፕትድ ቫልዩ ሃየር እንደሆነ ያሳያል ማለት ያ ነው ኢንዲኬሽን ፖዚቲቭ። ስለዚህ remember error can be positive or negative depending on whether the experimental value is greater or less than the accepted value ብለናል ቅድም ማለት። ስለዚህ if you have a negative answer that indicates that your measurement was less than the accepted value ማለት ነው. Whereas if you have positive value that indicates you that your answer or your experiment was higher than the accepted value ማለት ያ ነው የሚያሳየው ማለት። ነገር ግን when you calculate percent error ግን we take the absolute value of the error ማለት ነው።
ኤረር ላይ አብሶሉት ቫልዩ አንከትም ይስታል።
አዎ ምክንያቱም ምን መሰለሽ ኤረሩ አሁን ይሄ ከመቶ ምን ያህል ኢንከር እንዳደረግሽ ነው ይሄ የሚያሳይሽ። ይሄ ግን ኤረሩ ምክንያቱም deviation from the accepted value ብለናል አይደል? Remember error is defined as the deviation of the experimental value and accepted value ስላለን ከaccepted value ትልቅ ሊሆን ይችላል experimental valuation and in some case it can be less than the accepted value. ስለዚህ ምን ማለት ነው you can have positive as well as negative value ማለት so negative ሲሆን experimental valuation ትንሽ ነው ማለት ነው። positive ሲሆን ደግሞ experimental valuation ማለት አሁን ለምሳሌ if I gave you this another assignment ለምሳሌ positive ከመጣ ያ የእናንተ ውጤት ከአክሰፕትዱ ወይም ይሄ ትሩ ቫልዩ ከሚባለው በላይ ነው ማለት ነው ያገኛችሁ። ካነሰ ደግሞ ኔጌቲቭ ኤረር ይኖራል። ግልጽ ነው? ኦልራይት
ሚስተር ፐርሰንት ኤረሩ 2.59 አይደል እንዴ?
እስቲ በነገርኝ ፐርሰንት ኤረር
2.59 አይደል?
I think እኔ እንትን ስላልያዝኩ እኮ ነው።
No, Mr. 2.59 ነው።
2.59 ነው? ኦኬ ስለዚህ let's make this correction 2.59 ምንም ችግር የለውም። ይሄ አጣላንም ማለት ነው as long as እንትኑን እስካወቃችሁት። ግን አሁን እኔ ለምሳሌ ስሰራ ካልኩሌተር አልጠቀምም። ስለዚህ እናንተም እንደዛ መልመድ አለባችሁ ማለት ነው። so percent error 2.5 አገን እንትን ወይም እንውሰድ። now let us see uncertainty ለካ እንዴት ካልኩሌት እንደሚደረግ ኦኬ uncertainty ይሄ ደግሞ doubt in a measurement እንደማለት ነው። ስለዚህ uncertainty እንዴት ነው ካልኩሌት የሚደረገው? it is expressed by average deviation ማለት ነው። average deviation ማለት ምን ማለት ነው? individual measurements or experimental ማለት ነው in this case individual measurements minus average value over n. So let me explain this term መጀመሪያ እንትን ከማለት በፊት I think because this is very important. Let's say ለምሳሌ አሁን suppose we measure the length of an object and we happen to get 1.2 እንበል ለምሳሌ አሁን ለምሳሌ if the uncertainty is 0.01 ለምሳሌ አሁን ይሄን እንዴት እንደሚገኝ ያሳያቸዋል። ግን let us interpret what uncertainty means. So uncertainty plus or minus ማለት ለምሳሌ ሌላ ተማሪ ከናንተ አሁን ይሄን ሜዠርመንት ኦብጀክቱን ሜዠር ቢያደርግ under similar condition ማለት ነው that I will be certain enough that the measurement that you will obtain will be in between what 1.19 and 1.21. ስለዚህ ለምሳሌ ሁላችሁም እንደዚህ ሜጀር ብታደርጉት እኔ ሜጀር ያደረኩት with a certain confidence level ማለት ነው that I will be sure that your measurement will lie in this range. So ይሄ ነው uncertainty ግልጽ ነው አይደል? Now, is it clear how to interpret uncertainty? So when we say uncertainty ስንል ለምሳሌ እኔ ሜጀር አድርጌ ከዛ if I ask you to measure the same object under the same condition የሆነ ኮንፊደንስ ሌቨል ምናምን ይባላል አይደል? እንትን ላይ የተማራችሁት ስታት ላይ ለምሳሌ 95% ኮንፊደንስ ሌቨል ይባላል 99 ምናምን ይባላል አይደል? ሶ ለምሳሌ ያው እዚህ ላብ ብዙ ነገር ኮንስታንት የሆነ ነገር ስለማይኖር ወይም ክሎዝድ ሲስተም ስላልሆነ 95 እንበል ግን 95% of the time that I am confident that your measurement will lie between this and this one. ይሄ ነው uncertainty ማለት ስለዚህ አሁን ለምሳሌ the higher uncertainty ወይም the smaller uncertainty I mean the more precise ማለት ለምሳሌ ይሄን አሁን 1.2 plus or minus 0.001 ካረኩኝ ምን ማለት ነው 1.999 I mean 199 and 1.201 እንደማለት ነው አያችሁ so the more significant figure we have the more precise ማለት ስለዚህ አሁን ለምሳሌ ይሄ ቫልዩ እና ይሄ ቫልዩ I think next session ላይ እንማራለን the more significant figure you have the more precise your measurement is ስለዚህ አሁን ይሄ ማለት ምን ማለት ነው አሁን under the same condition I can be certain that your measurement will lie between these two values. So this is what uncertainty means. Now, how do you calculate uncertainty? So basically, uncertainty is expressed by average deviation. Remember, average deviation is calculated as sum of the individual measurements minus accepted value over n. N refers to the number of measurements or thread. And times 100 tarabutana. That will be your that would be 100. Okay, that would be your average deviation. So average deviation indicates American uncertainty. Now, let us see with an example. I think in this so for example, a student reported the following data of his trial in determination of the volume of a liquid whose actual volume is 6 milliliters. See, for example, if we tried this experiment 3 times, average deviation okay, average deviation sincera 5.9 minus 6, right? Plus 6.1 minus 6 plus 6 minus 6 over 3 እናደርገዋለን ማለት ስለዚህ ይሄ ስንት ይሆናል 0.1 and 0.1 አንዱ 0 ነው ያን እንተዋለን 0.2 over 3 now 0.2 over 3 ማለት 0.067 አይደል ግልጽ ነው አይደል ስለዚህ ይሄ ምን ማለት ነው uncertainty ስንት ነው ማለት ነው average እዚህ ጋር 6 ነው would you please mute your sound እሺ so now remember the average value is 6 here 6 ስለሆነ አሁን እዚህ ጋር አንሰርቲኒቲ ስንት ነው ማለት ነው? 6 + or - 0.067 ይሆናል ማለት ነው። so ምን ማለት ነው? that we can be certain that if somebody else did this experiment in under the same condition, that we will be certain to get between this volume 5 point እንቀንስና አንዱ መቀነስ ነው። so ከ6 ይሄን ስንቀንስ 5.933 and 6.067 ስለዚህ ምን ማለት ነው? uncertainty ማለት doubt in our measurement ማለት ስለዚህ አሁን እዚህ ጋር ዳውታችን ይሄ ነው ማለት so if you have an uncertainty of 0.067 ማለት ለምሳሌ አቨሬጁ አንድ ሌላ ተማሪ ቢሰራው under the same condition, that we can be certain that the average value of a 3 measurements will be we will be certain to get between these 2 values. But as used, no average, remember. So this refers to uncertainty. Now, can you do the percent error involved in the measurement? Did you know uncertainty? Is this clear? Blame Brown. Let's go. All right. Let's go. So, uncertainty can be expressed by average deviation value. ስለዚህ አሁን average deviation ምን ያሳየናል? uncertainty in our measurement ምን ማለት ነው? ለምሳሌ if I measure an object and if the object is this long ማለት ከዛ እዚህ ጋር ለምሳሌ 0.1 ነው uncertainty ከተባላችሁ ይሄ ኢንፎርሜሽን ከተገባ ምን ማለት ነው? can you tell me what this means ከተባላችሁ ይሄ ምንድነው የሚያሳየን? that ለምሳሌ ሌላ ሰው ቢሰራው ይሄን ኤክስፐሪመንት ወይም ይሄ measurement we can be certain that your measurement lies between this person. ስለዚህ ምን ማለት ነው? አሁን ይሄ ፕላስ ኦር ማይነስ ማለት 1.2 minus 0.01 እንደማለት ነው። ስለዚህ በደንብ ልጻፈው ሆለን 1.2 minus 0.01 እንደማለት ነው። so ይሄ 91.1 ስለዚህ 1.19 and 0.01 አድ ማድረግ ደግሞ it will be 1.21 ይሆናል ማለት ነው። so ምን ማለት ነው? if somebody measures the object under the same condition, that we can be certain that your measurement would lie between these 2 values, any value between these 2. Get that? So that is uncertainty. So እንዴት ነው ካልኩሌት የሚደረገው ነው ጥያቄ። so if you are asked to calculate uncertainty, all you have to do is calculate average deviation. ምክንያቱም average deviation ምን እንደሚያሳየን ማለት ነው? uncertainty ስለሚያሳየን። so to calculate average deviation ምን እንደምናደርገው summation of what individual measurements አለን ወይም values እንደማለት ነው minus accepted value. I mean accepted አልኩኝ average value ማለት ነው over n. n refers to the number of measurements. ስለዚህ ለምሳሌ እዚህ ጋር ይሄን ስንሰራ ምክንያቱም ስንት አለ 5.9 አለ 5.9 እሺ 5.9 6.0 6.1 ነው measurement or and assume that the true value is 6 ተብለናል 0.0 now አሁን እዚህ ጋር average value I mean average deviation ካልኩሌት ለማድረግ individual measurements ማለት እነዚህ ናቸው so ይሄ ሲቀነስ ይሄ true value ማለት ነው 5.9 minus the true value which is 6 አይደለ over so 6 እንበል ይሄ ሲደመር 6.0 minus 6.0 ሲደመር 6.1 minus 6.0 over 3 alright ስለዚህ ይሄ ስንት መጣልን 0.067 መጣልን ማለት ነው እዚህ ጋር ግን አቨሬጃችን ስንት ነው አቨሬጃችን 6 ነው now አሁን አንሰርቲኒቲው 0.067 ነው ማለት ለምሳሌ ሌላ ተማሪ ይሄን ኤክስፐሪመንት ቢሰራ that the average of the student would be this much plus or minus this much so ይሄ ማለት አሁን ለምሳሌ ብንሰራ 5 point ይሄን ቀንስና 9 I think 3 and 6.067 is ነው ስለዚህ አሁን ብንሰራ ይሄን ኤክስፐሪመንት that our average will be between these 2 points any point between these እናገኛለን ይሄ ነው አንሰርቲኒቲ የኢንዲቪጁዋል ነገር average will be between these two values ስለዚህ አንሰርቲኒቲያችን ስትሆን ማለት ነው 0.067 ሆነ ማለት እሺ ግልጽ ነው አቤት
true value ነው plus or minus የምናደርገው
ኖ true value አይደለም true value ማ አይደለም አቨሬጁ ነው እንጂ አሁን እኮ true value ማ ኦሬዲ ከሪፈረንስም ይሁን ለምሳሌ ይሰጥሽና ይሄ አይቀየርም ግን ኤክስፐሪመንታል ቫልዩ ለምሳሌ እኔ ማነበውና እናንተ የምታነቡት አንድ ላይ ሆን ይችላል አይደል ስለዚህ ፐርሰናል እንትንም እኮ አለ ግልጽ ነው አይደል የፐርሰናል ዳይሜንሽንም አለው ለምሳሌ ቴምፕሬቸሩም አሁን እኔ ስሰራና እናንተ ስሰሩት አንድ ላይ ሆን ይችላል ሌላ ደግሞ እኛ ኮንትሮል ልናደርገው ማንችል ነገር ግን አፌክት ሊያደርጉ የሚችሉ ኤክስፐሪመንቱን አሉ ግልጽ ነው አይደል ለምሳሌ እኔ ስሰራ መስኮት ከፍቼ ሊሆን ይችላል ምን ማለት ነው ቬንቲሌሽን ነበረ somehow አፌክት ሊያደርጉ ይችላል እናንተ ደግሞ ዘግታችሁ ልትሰሩ ትችላላችሁ ስለዚህ አሁን እኔ ሜጀር ማድረገውና እናንተ ሜጀር የምታደርጉት አንድ አይሆንም ነገር ግን አሁን ለምሳሌ 3 ጊዜ ሜጀር ብናረግ አሁን ሪሜምበር እቺ ኮንፊደንስ ሌቨል ያልናት አለች ኮንፊደንስ ሌቨል ማለት በቃ 95% of the time አቨሬጃችን በዚህ መሃል ይሆናል ይያል ስለዚህ እኔ ብሰራም 6 ላመጣ እችላለሁ እናንተ ደግሞ 5.94 ልታመጡ ትችላላችሁ አይሽ so this value lies in this range አይደል ስለዚህ አሁን የአንሰርቲኒቲ እንትኑ ነው ማለት ግን we can be certain that our measurement will be between these two values እያለ ነው ምክንያቱም ብዙ ኮንትሮል የማናደርጋቸው ነገር ስላለ ነው ግልጽ ነው እሺ ስለዚህ ይሄን እቺን ስራና እናብቃ አይ ቲንክ እንትናችን እሺ አይ ቲንክ ኤስ እንስራ እሺ ኤ ቶሎ በሉ እስቲ remember the actual value or the true value is 3.5122 so what type of error or errors are involved in the measurement
Student aim random and student aim systematic.
Student. Okay, I think ትንሽ እንቀይረው መሰለኝ
Student aim systematic, student A
እንትን
random.
እናድርገው አይሻል? hold on ግራ እንዳያጋባችሁ let's see እሺ ይሄን እንደዚህ እናድርገው I think ጥሩ እንትን አልመረጥኩም ማለት ነው እነዚህን አንዳንድ እናድርጋቸው እሺ okay I think የመጀመሪያው so that we all be clear አሁን እዚህ ጋር ግራ እንዳይገባችሁ ለምሳሌ የመጀመሪያው measurement 3.5124 እዚህ ጋር 3.5121 እናድርገው 2 ከሆነ ትንሽ እንትን እንዳይላችሁ ብዬ ነው ግልጽ ነው አይደል remember አሁን systematic ስንል ምን ማለት ነው errors that produce what
All higher or all lower?
Exactly, all higher or lower than the accepted value ብለናል አይደል ስለዚህ አሁን እነዚህ ምን አይነት ቫልዩዎች ናቸው አሁን አቨሬጁ ወይም አቨሬጅ አልኩኝ I mean እንትኑ ማለት ነው accepted value 3.5122 ነው አይደል እነዚህ ካያችሁ ግን አንድ ሁለት measurement below the actual mass አለ and the rest 3 are above the actual value አይደለ ስለዚህ እነዚህ አሁን ምንድናቸው ማለት ነው above and low ናቸው ማለት ነው ስለዚህ ምን አይነት ኤረር ነው ኢንከር ያደርጋለው student aim random excellent ጎበዝ let us proceed to the second one አሁን ይሄ ግልጽ ነው እሺ student aims all right እሺ የስቱደንት ኤን እንጨርስና ሌላ ጊዜ ደግሞ አንሰርቴኒቲው እና ፐርሰንት ኤረሩን ካልኩሌት አድርጋችሁ ለኔክስት ዊክ ነው እሺ አሁን የኤን ስንስራ ምን አይነት ኤረር ነው ኢንከር የሚያደርገው what type of error is involved in the measurement of student n
random
systematic exactly ምክንያቱም all these values are what
Higher.
right? Exactly than the actual mass really ስለዚህ if all values happen to be above the accepted value ምን አይነት ኤረር ነው ኢንከር የሚያደርገው ሲስተማቲክ ይሆናል ማለት ነው ስለዚህ እንደዚህ አድርጋችሁ ስለዚህ ለኔክስት ዊክ ሲና ዲስሩና ከዛ በኋላ ወደ ሲግኒፊካንት ፊገር እንቀጥላለን ማለት ነው እሺ all right thank you